And we're going to start with a lesson today on surface area and volume of a sphere. Now, we are going to have two handles that you are going to complete after this. So those will be your homework and I'll have you submit those, but I'm just going to go through the lesson with you on the surface area and the volume. So let's just first of all talk about a sphere and what a sphere is. This is 8.6. You should have this in your notes. And the definition of a sphere is just simply a three-dimensional round-shaped object, okay? Baseballs, oranges, globes, they're all examples of spheres. So I'll have you write that out as your definition. And basically, as you're writing this out, the real mathematical, technical definition of a sphere, not this kind of a little more layman's term of a three-dimensional round-shaped object. But the true definition is if you were to go right to the center of the sphere right here, the distance from the center to anywhere on the surface is the exact same length. So in a sphere, and I'll see if I can get one that looks 3 dimensions. Right here, let's say. Exact same one. But in a sphere like this, if this is truly a sphere and I find the middle, and the middle is right, let's say there, distance from this middle to here, or the distance to here, or the distance to here, or the distance to here, and this is all 3 dimensions, anywhere you go is the exact same measurement. There's not one that's going to be longer than the other. That's the technical definition of a sphere. Now, there's 2 things we can find with this sphere. We can find the formula for the surface area or for the volume, and these are both on your formula page. But for the surface area, notice it's 4 pi r squared. The only thing you need is your radius. Give me the radius, I will tell you what the surface area is. Okay, give me the radius, I'll tell you the surface area. It's just one measurement. A lot of these other figures, you need length, width, and height. You need radius and height, but for a sphere, just your radius. And just know that if you know the surface area of your sphere, you can determine the radius. And I'm going to do that with you right now. So I'm going to go A equals pi. I'm going to put a 4 first. 4 pi r and to the power of 2. So there is the formula for the surface area of a sphere. Now, how do we move from surface area to the radius? This is back to 4.4, rearranging equation. We're going to now say, well, wait a second. If I want to get the r by itself, I've got to get rid of the 4 pi first. So let's get rid of this, and watch what I'm doing here. I'm going to take the 4 pi on this side, and I'm going to say, I'm going to get rid of multiplying by 4 pi, but that means I have to go to the other side, and I have to divide by 4 pi. This would be my new updated equation, r squared instead of 4 pi r squared. I now have the r squared by itself. And what's the last thing to do to get rid of the squared? We're going to take everything, clone it, come on. We're going to take this and clone it. And the only thing we're going to do is we're going to get rid of this squared. But on this side, how do you undo a square? You square root it. So I'm going to put a square root sign, hopefully right there. And there is the little formula where if somebody gives you the surface area and says, what's the radius? You just plug in You take your surface area divided by 4 pi, and then take your square root. All right. So the only other thing that I would say is if I was ever given this, I'd always write the r first. So I would take this and get rid of this here. I would write r equals on this side, and I would say, here's the little formula that I would use. So we just went through and we just figured it out. So is everybody okay with that? Is everybody okay with how we took the surface area, solving for the surface area, and we rearranged it to solve for the radius? So for this formula right here, it's basically telling you, give me the radius. I'm going to square it, multiply it by pi, multiply it by 4, and I'll tell you what the surface area of that sphere is. Whereas this formula here is the exact same. Mr. Bracken, Dave. But this says, give me the surface area, not the radius, the surface area. I'm going to divide it by 4 pi, and then I'm going to take the square root, and that will tell me my radius. Okay. So once you get that copied out, and I'll go to here, I want you to try the 2 questions at the bottom, question 1 and question 2, and when you get done, put your hand in the air, okay? When you get done these 2, everybody should have their hand down right now. When you get done those 2 questions, put your hand in the air. First one's pretty straightforward. You're given the radius. You want to find the surface area, so you just write out your formula, plug in your radius, 4, shift, pi, open up the bracket, put your 4, and square it. And I end up with 64 pi, but I'm going to hit my S to D key, and I'm going to get around 201.1, I would say. I'm going to round to 0.1. 1.1, and this is meters squared. Okay. First one's done. For the next one, okay, determine the radius of the sphere with a surface area of 215 centimeters squared. So notice in this question, we know the surface area. We are asked for the radius. Now, we already went through this whole conversion. Okay. And I'll actually just do this another way. We actually went through this conversion, but look what I did on this one, okay? A equals 4 pi r squared. I plugged in for the A right off the bat. You don't have to, you could have just used this right here, okay? And I'll show you how this works later. But assuming we didn't do this ahead of time, and we just had this question, you could have plugged in the 215 for the A without rearranging. We divide this by 4 pi, and 215 divided by 4 pi is going to give you this for your r squared. And now you take the square root, and you're ending up with 4.1 centimeters approximately. Now, you could have taken this right off the bat over here. I'll just put this here. And you could have said, you know what? My next line is equals. I'm going to open up a square root and fraction. It's 215 all over 4 pi. And in your calculator, You could have put 215 divided by 4 pi with a square root, and you would have gotten your answer, which should be the exact same. I'll just do this over here. Square root, open this up, 215, all divided by 4 shift pi, and we get 4.13. Do you see how we get the exact same answer, 4.1? So this one, 4.13 or 4.1. Either way would have worked, okay? All right, is everybody okay with this? Any questions with these two questions here? Because this all dealt with surface area, and all you need to find the surface area is the radius, okay? Any questions on the front page, surface area? So whether you rearrange your formula and then plug in, or whether you just plug in and take stuff away, like divide by the 4 pi, take the square root, you're going to get the exact same answer. Either way will work. All right, can I move on to the next page? Move on to the volume. All right, I'll come back to this if anybody needs it, okay? All right, volume. So once again, the only thing that you need for volume is your radius. The only thing, but it's a little different formula. It's 4 pi r to the power of 3 cubed, all divided by 3. And don't forget the dividing by 3 part, okay? Four pi r cubed divided by 3. Now this is on your formula page. Both of these are right on the back under your sphere, surface area and volume. A question that comes up a lot in grade 9, whether it be on tests or quizzes or EQAO or going forward, is always putting a sphere inside of like a box and seeing how much empty space there is. So if you can picture buying a brand new baseball or soccer ball or basketball, even tennis balls where they come in a container, when you put them inside, they take up a certain space, but there is space left over. So you can actually determine the empty space in a container by subtracting the volume of the object from the volume of the container. Find out how big the container is, take away how big the object is, and whatever's left over is going to be the volume of the empty space. So let's take a look at this very first question. As long as you guys are okay up to there, let's take a look at this first question. A baseball just fits inside a cubic box with side lengths of 8 centimeters. So you take this baseball, and it's a very expensive baseball, and it fits right inside the box. So it's touching all of the sides of the box. It just fits in. Calculate the volume of this baseball to the nearest centimeter. So we're rounding off to the nearest centimeter. So what shape is this baseball? Well, it's a sphere. So I'm going to write out the formula for the sphere. Volume of the sphere, I put a little s for sphere, 4 pi r cubed divided by 3. Now, the only thing I need is the radius. And I look at my diagram and I say, oh, they didn't give me the radius. They told me the dimensions of the box, but not the radius. They probably forgot it. I can't do this question. But then all of a sudden it clicks in and you're thinking, well, wait a second. If this whole side is 8 centimeters, then going from side to side in this sphere is also going to be 8 centimeters because it fits just inside the box. It's touching every side. So if this is 8, The diameter of this sphere is 8. So we know the radius is going to be 4. So in my diagram over here, I will write 4 centimeters.
Sir.
Yep.
So you know how like we're in an equation, if you can't find the, I know that you can just find it like that, but if you were to do the 4 times, since this is a division, what would you do now? Would you do 4 pi times 3 equals r squared? I mean r cubed. And how would you like do a cube? How would you
I'm going to do that right now.
like, you know how you undo it?
You're getting ahead of me. I haven't even gotten there.
Oh, okay, sorry.
So we know the radius is 4. Now we plug in. So the only thing that changes is there's now a 4 where the r was. Our radius is 4. So how do we finish this? We grab our calculator. We have a numerator and a denominator. So we are going to open up a fraction, and I'm going to start with 4 shift pi. I'm going to go to 4 cubed. So open up a bracket, 4 and my bracket. And if you notice, this is why I'm liking this calculator so much. Here's your squared key on your calculator right there. But we're going to move to your cubed key, which is up and over right in here. That's x cubed. You can see the little 3. Hit your down key to get to the denominator and hit 3. Now, when I hit enter on mine, I'm going to get my answer in pi units, but I want to change this S to D. So I now have 268.0 or decimal 1, but it says to the nearest centimeter. So I'm going to get 268 centimeters cubed, nearest centimeter. Is that okay with everyone? Everyone saw how to do that on the calculator? 4 pi bracket with your radius inside cubed. Your cubed key is right here. And then make sure you divide by 3. All right, now, how much empty space is in the box? Well, how are we going to do this? How are we going to figure out the empty space?
Find the volume of the entire cube and not the sphere, and then just subtract the volume of the box from the sphere.
Exactly. Just say subtract the sphere from the box. Just the other way around. That's all.
Okay.
Yep. So we ended up with the volume of the box is length times width times height, which is 8 times 8 times 8, which if it was just a completely empty box, 512 centimeters cubed. So a completely empty box is 512 centimeters cubed, just like Ashton said. But we're going to place a baseball inside that takes up 268 of these 512. So we subtract the 2, and I didn't listen to the question because I kept decimals going. And I end up with this right here.
Sir, we can't see your screen now. We can see your team.
All right, is everybody okay there? Any questions on that one? So you can see that, roughly speaking, the baseball and the empty space are almost the same. It's almost like they take up half and half. Pretty close, not exact, but pretty close. Okay. All right, let's do the very last one here. Determine the radius of a sphere with the volume of 300. Okay, here we are again. We're doing the opposite of what the formula is set up to do. The formula is set up saying, give me the radius. I'm going to do my formula and give you back the volume. But we want to spin it around now to say, okay, I know my volume. What's the radius? So we still start with our formula. There it is. Now, you can veer off two different ways from here. You can just completely rearrange your equation to solve for R first and then plug in your volume, or you can plug in your volume right away like I did. I just plugged in the volume as 300. Now, what we're going to do is peel away these layers, peel away, like almost like peeling away the layers of an onion. Or lately, when I've gone outside, I've worn my Carhartt kind of pants that I wear, like my insulated pants. I wear 2 hoodies plus a coat plus toques plus glove. I just bundle myself up. And when I get back into my garage, which is like a heated garage, which is unbelievable, I take off my toque, I take off my gloves, I take off the 2 hoodies and the Carhartt insulated pants, and then I'm just back to myself. I'm peeling away those layers. Right now, what we want to do is get this all by itself, this R right here. So we've got to peel things away. What's the first thing we're going to peel away here is this dividing by 3 so we can expose the whole numerator. How do you get rid of dividing by 3? You bring it to the other side and it's multiplying by 3. And 300 times 3 gives me 900 on this side. I got rid of this dividing by 3. And that gave me 900. Now, how do I get this R cubed by itself? I've got to divide by 4 pi. So 900 gets divided by 4 pi, and that leaves me my R cubed. I'm slowly but surely taking away the layers to get to that R all by itself. And now 900 divided by 4 pi, I grab my calculator, open up a fraction, I go 900 up top, I go down below and I put 4 shift pi, and I get 71.6. There it is.
Sir.
And here's the very last thing, okay? The very last thing. This is the one new part for everybody. I know how to undo a square. We square root it. I'll come right back to this page. Just bear with me here. Do you see at the bottom of the first page with the surface area? When we wanted to undo this squared, do you see how we took the square root? That's the opposite of squaring a square root. The problem with this one is, do you see how we're cubing? We have to undo a cubed. So it's not something times something equals 71.6. It's something times something times something. It multiplied by itself 3 times. So take a look right here on your calculator. Do you see the square root key right here? Take a look what's above it in yellow. Do you see the yellow with the little 3 out front? It's the square root key, but the yellow key above it. This is called not your square root because you're undoing a square. It's called your cube root because you're undoing a cube. So if we clear our memory and go shift and the square root key, do you see the little 3 sitting in front of the square root key? This is now a cube root, not a square root. Something new for you guys. And I want to know, what is the cube root of 71.6? What number multiplied by itself 3 times gives you 71.6? And by hitting equals, we're getting an answer of 4.15. That 4.2, I rounded it to 4.2-ish. That is going to be the radius of this sphere to give us 300 meters cubed. And just to verify this, if I go back to my volume of a cube, okay, so open up a fraction, 4, shift, pi, open this up. If my radius was 4 and even 0.15, because I know I rounded, and I cube it divided by 3, do you see how I just took the volume of a sphere and I put in what I know the radius was? When I hit enter, I'm really hoping to get 300 here. And do you see how close I am? 299.38, just because I rounded. I know that's now my radius, 4.15, 4.2. All right. And that right there brings us to the end of this lesson. And I'm just going to stop the recording.